All right, so if you recall, we have done area of regular polygons. The formula for a regular polygon is 1/2 apothem times perimeter. All right, the apothem, of course, is this perpendicular distance from the center to one of the sides. And remember, perimeter is the entire distance around. So that is each side multiplied by the number of sides. Okay, and so prior to this, we had to use our 30, 60, 90 triangles, and we only did polygons that created a 30, 60, 90 triangle. We are now going to do other polygons because we can use right angle trigonometry to figure out that missing side length. So this example that they give us here is how many sides? How many sides for this particular figure here? This is an octagon. We have an 8-sided figure. And so to figure out, first of all, what one of these angles in here is, what just one of them is, they're all the same. You're going to take what an entire circle is, which is 360, and you are going to divide by 8. 360 divided by 8. That actually gives you a 45-degree angle, all right? Now, the 45-degree angle represents the total angle, but we create this apothem right here. This apothem. When you create this apothem, you cut that angle in half. And so if you were to take this triangle right here, this right triangle that's created by the apothem, it cuts that 45 degrees in half. All right, and so when you take that out, you get this little triangle right here. And so if you cut that 45 degrees in half, you will see that you have a 22.5 degree angle right there. 22.5 degree angle. This side right here is the apothem, which is what we need. So then how do we figure out this? Well, they gave me the entire side length, and just like the apothem cuts the angle in half, it also cuts that side in half. So this is 6. So I have an angle measure here, and I have a side length, and I need to figure out the other side length. So I am going to use right angle trigonometry to do that. You just did it on bell work, and so we're going to do it here. I am going to take this angle, and I'm going to label this triangle based on that angle. So the side length of 6 is going to be my opposite side. The apothem is going to be my adjacent side. And so which trig function am I going to use to figure out that side length? Yeah, I'm going to say, well, the tangent of 22.5 degrees should equal my opposite side over my adjacent. And remember, when your variable is on bottom, you are going to divide, which means your apothem is always going to equal half of your side length that they gave you divided by the tangent of that angle that's created, half of that angle that was created. Your apothem will always equal that, always. And so you don't have to worry about, is this a 30 degree, is this a 60 degree angle, is this whatever it is, you know that you will automatically take your number of sides divided by 360 and cut it in half. That's your angle measure. Take one of your side lengths and cut it in half. And your apothem will always be half of the side length divided by the tangent of half of the angle. All right? Which, by the way, when you do this, you get approximately 14.5 centimeters. So this is my apothem length. My apothem is 14.5 centimeters. The other piece of my area is perimeter. My perimeter, one side is 12. I need to multiply that by 8 to get my entire perimeter, right? So I'm going to get 96 centimeters as my perimeter. And then I am just going to plug it in. My area then is going to be 1/2 my apothem times my perimeter. And you will get an area of approximately 695.3. All right. Let's look at example 1. Let's look at example 1. All right. So we have, they want the enclosed area that is enclosed by the Pentagon that's in Washington, D.C. They have given me some information on it. 921 feet long is one side. Pentagon means it has 5, right? So they took the 360, they divided by the 5 sides, and they got 72. All right, so if I want to find my apothem is always going to be half of one of my sides. All right, so half of one of my sides, which is the 921 divided by 2. So when they did half of the side, they got this 460.5. So my apothem is going to be that half, 460.5, divided by the tangent of half of that angle. Half of this angle is 36. Tangent of 36 degrees. All right. And then I want to actually find the area. So my area is going to be 1/2 my apothem, and you can actually put all of this in. You don't have to calculate it. If you calculate it, make sure you show me how you rounded it in the process. And then times perimeter. Well, perimeter is going to be the 921, one side length, times my number of sides, 5. And that will give me my square footage, all right, which is this big square foot, over 1 million here. All right, so that is my square footage. That's the area. Now, I will say they specifically wanted it in acres. All right, and they told me what 1 acre is. 1 acre was 43,560 square feet. So what am I going to do to the square footage to figure out the acreage? If 1 acre is 43,560 and they want it in acres, you're just going to convert it. So 1 acre is 43,560 square feet. You just divide. And when you divide, you get about 33.5 acres, which is pretty big, actually, for the Pentagon. All right? That's how many acres it takes up. 33.5 acres. So your apothem will always be half of your side length over the tangent of half of one of those interior angles. The first one is asking for CPD, which is this angle right here. So to find just the interior angle, you're going to take the number of sides and you're going to divide 360 by that. So you should have just gotten, once again, like we did from the example, 72 degrees. The next question is CPM. They want that angle cut in half. So you should have just taken 72 divided by 2 and gotten 36. 36. And then they wanted the angle PCM. Well, you know that this one's 36 and you know that this one is 90. So you could just have subtracted from 90 and you would have gotten 54 degrees for that one. 54 degrees. Because you had one triangle and you had 2 of the 3 angles in a triangle. All right. Find each length to the nearest side. The first one is M to C. M to C. Well, they gave you 6 as the entire side length. So from M to C, you should have gotten just 3. From P to M, you could use your right angle trigonometry. You could have taken that 3 and divided by the tangent of 36, and you would have gotten 4.1. 4.1. So you have your 4.1 and you have your 3. And the last one they're asking for is the hypotenuse. And you could have just used Pythagorean theorem here. A squared plus b squared equals c squared to get 5.1. Or you could have used another trig function, either sine or cosine at that point, if you wanted to use a trig function as well. The last thing is finding the area. So the area is going to be 1/2. Your apothem, which you found when you found PM, your apothem was 4.1. And then your perimeter was 6 times 5, which is 30. So to find this one, you would have been 1/2 apothem, 4.1 times perimeter, which is 30. And you should have gotten 61.9 square inches. 61.9 square inches. So at the top of page 591, you will see this triangle. MNO is the triangle. And they have created an altitude. Remember, an altitude goes from a vertex perpendicular to the other side. All right, perpendicular to the other side. They have given us the base of this triangle. So they've given us the base of the triangle is 15 inches. They have given us one of the sides, which is 10 inches. But in order to find the area of a triangle, I need to know the base and the height. The area of a triangle is 1/2 base times height. I do not know my height here. So to create the height is the altitude, is the perpendicular distance from the vertex down. They drew that, which created this right triangle. And we now have one angle measure of a right triangle and one side length of a right triangle, specifically the hypotenuse of this right triangle. And we really need to know this side right here. And so I'm going to label the triangle based on that 40 degrees. And if I label it, the height that I am looking for is opposite. The hypotenuse, the 10 inches, is my h here. So my hypotenuse is the 10 inches. So I am going to then say which of my trig functions deals with opposite and hypotenuse. So which of my 3 trig functions deals with that? Sine. So to find the height of my triangle, I could say sine of 40 degrees equals opposite, or the height that I'm looking for, over hypotenuse, which is 10. So I just take sine of 40 and multiply it by 10, and I will get my height. All right, so I can take this piece right here and plug it in for my height. You can either plug it in and round it, or you can take it all at the end. So you could just say, well, the area of this triangle is going to be 1/2 my base. What's the base of the triangle? What's the length of the base of this triangle? 15. And then the height is going to be what happens when you say 10 times sine of 40. 1/2 base times height. And you'll get approximately 48.2 square inches. 1/2 base times height. All right, look at the next example. Example 2. Find the square footage of a triangular lot with sides of 80 feet, 90 feet, and 110 feet. So they've given me all 3 sides, but that still actually does not give me the height of the triangle. They did, however, give me the angle between the 2 longest sides of 46 degrees. So they gave me this. So once again, I'm going to label it. My height is opposite. The hypotenuse is 90 if I use this angle, this triangle right here. So the sine of 46 degrees times that 90 should be my height. And then I can plug it in. 1/2 my base, 110 times my height. And that will give me my area. So this creates this formula here. If you look at the middle of that page, or bottom rather of that page, you see the side angle side area formula. Side angle side. So let's say you have 2 of your sides and 1 of your angles in between it. You can create that right triangle, and you'll notice a pattern that's happening. It's your side length times the sine of the angle. The side length times the sine of the angle. This formula. If you look at the bottom of that page, if we look and see what happened here, you can see that you end up having 1/2 the 2 side lengths, sine of the angle. 1/2 the 2 side lengths here, and the sine of the angle that was created by the 2 side lengths. And that's where you get that formula. So when you have any triangle, you can take the 2 side lengths and the angle created by it and use this formula. You have 1/2 your 2 side lengths, sine of the other angle. So notice how they labeled this triangle. Notice how they labeled this triangle. You have A, B, and C. When they have little a, that is the side opposite of angle A. So it doesn't matter that you memorize the formula. You need to memorize that you have 2 side lengths and the angle that's created by those 2 sides. So if you have the C and B, you're going to use the sine of the angle that's created by that. If you have the C and A, you're going to use the angle that's created by that. So you don't really have to memorize which one's which. You just have to know that you are using the 2 sides and the angle created by those 2 sides to find this area. So the area is always going to be 1/2 your 2 side lengths and the sine of the angle that's created by the two side lengths. All right, so 1/2 the two side lengths and the area created by the two side lengths to do it. So go ahead and try one of these. Look at what happens when you do number 13. Find the area of the triangle. Your new formula here, instead of just 1/2 base times height, since you don't have the height, is created from that using trig. So we're going to say it's going to be 1/2 your side lengths, which they gave you were 18 and 20, times the sine of your angle that's created by those two side lengths. So you're going to say the sine of 38 degrees. So this is how you would have put it into your calculator. This is your base right here, and these two multiplied would be your height. And so when you do that, you should have gotten 110.8 square feet. 110.8 square feet. So when we get into pre-calculus, we will actually show how this is derived. But in order to use the side angle side, you have to have an angle, right? So you have to have that angle in between to be able to use that formula. This formula is you can use just your side lengths. You have to understand what those side lengths represent. So A, B, and C obviously are your side lengths, but in your formula you have this little S. This little S that is in your formula right here. And it is right there all the way across. You have S times S minus one of your side lengths times S minus the second side length times S minus the third side length. So what is S? S is half of your perimeter. So to find S, you take all of your sides, add them up, and divide by 2. All right, half of your perimeter is that S. If you take half of your perimeter and multiply it by the difference between each of those sides and take the square root, that will also be your area. This is called Heron's formula, and we'll actually derive it when we get into pre-cal. We'll actually see where it comes from in pre-cal. So let's see how we use it and which one we would use. So A, if I have something like A, I'm going to use my first formula. I have two sides and the angle in between it. I am just going to say, well, that's going to be 1/2 my two side lengths times the sine of my 75 degrees. That will give me my area for this one. All right. But if I have something like B, I do not have any of my angles. And so I'm going to have to use Heron's formula for this. And so for Heron's formula, I'm going to add up the 10 plus the 7 plus the 9 and divide by 2 to get my S. All right. And then I'm just going to plug it in. I'm going to say my area for this one is going to be the 13. All right, the 13 times 13 minus 10. What's 13 minus 10? 3, right? And then 13 minus 9, so times 4. And then 13 minus 7, 6. And that will give you the area if you have all three sides. So if you have the angle and the sides and this angle in between, you are just going to use your area formula using your sine. If you have your three sides and you do not have any of your angles, you want to use Heron's formula. So you want to use your S, which is your perimeter divided by 2, and then just multiply that by the difference between each of the sides and take the square root. So you have to know both of these formulas. You have to know the one if you have the angle in between, or if you do not have the angle in between, but you have the three sides. So go ahead and try one of them with the three sides. Page 593, number 17.